It just records the screen and my voice or your voice if you answer. I can't see to post on Canvas so you have it to refer to later. All right, so first, when you hear the word solution, what comes to mind? And then hands, or we could do the other day, I have an answer, either of those. You said writing something down?
Yeah, right.
Okay. Anyone else have something that comes to mind when they hear the word solution?
An answer to something?
An answer to something? Usually an equation. Let's combine those two and say an answer to an equation. Usually this answer to whatever the equation is something that makes the equation true. You end up making a true statement. So we kind of touched on that the other day when we were doing the math riddles. But now, let's say we solved whatever. We got some answer. How do we determine, is this answer the actual solution or not? Franklin?
Wouldn't it be replace the x with 5?
Mm-hmm. Does anyone still need this? If at any point I'm going too fast or you need me to go back, just let me know. Sometimes I do that. Also, my handwriting is not the best, so if you can't understand what I'm writing, just let me know. But yes, we're going to take that 5, we're going to put it into x. I'm going to use parentheses anytime you do that. So 13 and then parentheses 5, like 7 equals 28. So we would then multiply. So 13 times 5 would give us, you can say this out loud.
65.
65. And 65 minus 7, would that give us 58? Because we get 58 equals 58, we end up with something that is a true statement. Anytime you end up with a true statement, we can say, yes, this is a solution. This is a really good tool for when you are when we get into solving. You get an answer, maybe you're not sure, or maybe you're working with someone else and they got a different answer. You could both put in your answer or your solution and see which one of you got the correct solution. If you end up making a true statement, that one is the solution. If you end up making a untrue statement or an untrue statement, then that is not the solution. Questions on number 1 before we do 2? A lot of this is going to feel familiar or like review, like you've done this before. A lot of AFDA is review with some new stuff, but we also start off easier and then get into the more hard stuff. So we already determined that 5 is a solution to this equation. So -5 probably shouldn't be, but we're still going to test it. So we're going to put -5 in now, and then simplify this and see what we get. Instead of positive 65, we'll now end up with a negative 65. If you are doing this in your calculator, this button at the bottom, this button at the bottom is your negative. You want that for the negative 65, but use this for your minus. And what would that give us?
Negative 72.
Negative 72. Is this a true statement?
No.
Negative 72 does not equal 58. So this is not a solution, which we kind of knew already because 5 worked, -5 shouldn't work. Do we have any questions on how we determine if something is a solution or not? I want you to try 3 and 4. I'll give you a couple minutes to do that, and then we'll come back and talk about them. Collectively, you can just say your answer. Did we find that this was or was not a solution?
It's not a solution.
Was not. Did it appear any was? Did anyone want to see this or need to see it? And then number 4, was this or was this not a solution?
It's not a solution.
Was. Do we need to see this one? Do you want to see this? Okay. Alright, so for this one, we have y is negative 34 over 2. We're adding 5. And then our order of operations, we need to divide first. So this would give us negative 17. And then if we add these two, we would get negative 12. So this should have been a yes. Do we have any questions about how to determine if something is or is not a solution? Do we feel good that we could do that? Yes. Go on to the next page. So these problems, they are already solved for us, and we're trying to figure out what they did. So we're going to be using these properties: addition, subtraction, multiplication, division, property of equality. That means they did it to both sides. They added to both sides, subtracted to both sides, da-da-da. Distributive, they have something in parentheses, something outside of the parentheses, and they're multiplying it to whatever's inside. So think about this like you were trying to explain this to someone and you were trying to explain to them what happened. What did they do? Okay? So for number 1, this is our given. This was the original equation. From step 1 to step 2, what changed or what property did they use? And let's do hands, or I have an answer, Casper. Distributive, property. They took that 2 and they multiplied it to everything inside. You can shorten this if you so choose. But distributive property would be what happened. What about from step 2 to step 3? What did they do here? So subtraction. Subtract what? Josie?
Between the negative, the subtract 18 and negative 10.
So it's when you were close. You see the subtraction, but that's not what they're doing to get to the next step. They're adding the 18 to get to that 8. So this would be addition, property of equality. So I'm just going to shorten that. Add POE. Property of equality is what that stands for. And then from step 3 to step 4, what do we do there?
Division.
Usually that's the last step, but sometimes that's not always the case. So division, property of equality. Do we have any questions on number 1? A second here, I don't want to go too fast, but we're going to move on to number 3. In number 3, so we have our original. What change or what property did we use to get from step 1 to step 2? What would we have subtracted? Oh, in number 3. What did we multiply? So this entire thing was being divided. There's divided by 2. So to get rid of that, we would have multiplied both sides by 2. These 2 would have canceled to become 1. which is why we end up with 14 on the other side. The remaining steps are very similar to the one we just did. From step 2 to step 3, what did we do there? Right?
We did
Addition. What did we add?
1 to each side.
And then Sloan, I saw your hand up. Did you want to answer the last one?
Yeah,
Division. And we divided 5 both sides. That looks like a J. Don't know if that's any better. Right. Questions on that one? Take a minute or so and do number 2, and then we'll come back and I'll write the answers and we'll talk about that. Answers up here, and then you can see if yours match or if they were different. We'll talk about that. So this first one was subtraction, property of equality, and then multiplication, property of equality.
You should have one.
So here, from the first one, it shows that we're adding, but to get rid of that, we would have to do the opposite and subtract. And then in this last one, it's already dividing, so to get rid of it, we have to multiply. So whatever it says is not what you're doing, it's the opposite of whatever it says. Questions on that? So in this last one, we're not looking at what it's actually doing, because what it's actually doing is dividing, right? But we're thinking about how this got to this. To get rid of the -3 is already dividing, so we have to do the opposite and multiply. That's right. To get to make sure these cancel, and what we do one time we have to do the other. So we ended up multiplying. Great. On to the next page. So this kind of goes back to the very first question I asked. What do you think of when you hear the word solution? So we said an answer to an equation. I'm going to add on to that for this to find a solution that makes an equation true by using inverse operations. To find a solution that makes the equation true by using inverse operations. Find a solution that makes the equation true by using inverse operations. So if I asked you, what is the inverse or the opposite? How do we undo addition? You can say this out loud. Subtraction. And I'm just going to draw arrows to connect these. How do we undo, or what is the inverse of division? Multiplication. What about if we squared something? What is the inverse of that? So in this one, it would be square root. Does anyone still need this sentence? So think about like 2 squared. 2 squared, or 2 times 2, or 2 to the second power is 4. if I took the square root of 4, we would get 2. So they're undoing each other. And then cube and cube root are also opposites for inverse operations. If we took like 2 to the third power, so that's 2 times 2 times 2, and then that would give us 8. If we took the cube root of 8, that would be what times itself 3 times would give us 8. It would be 2. So they undo each other. So as we're solving, we need to keep those in mind, those inverse operations. Take a second, read this either up here or on your papers. These are good guidelines, so if you get to a problem and you're not sure how to start, work through these kind of steps. If they have parentheses, you're going to be distributing something. If they don't, move on to the next step. If they have like terms, so same things with multiple things with the same variable, there we go, or multiple things without a variable, those would be like terms, but on the same side for now. We'll talk about different sides here in a second. And then our goal is to try to get our variable by itself. We're going to be moving things by adding or subtracting, dividing, multiplying. But usually we do the moving before multiplying or dividing, but it depends on the equation. Okay. So I want you to look at these 10. Look at them and see which ones give you anxiety. I don't know how to start that one. That one looks hard. Can we go through that one? Whichever ones you see, we're going to go through those together. So take a second, look at those, and then when you have one that you want to see done up here, raise your hand, and then I'll circle that. Angela? 3. Julia? 10. Nita? 6. 8. Any others? Okay. Well, start those right now. We may not have a chance to do all of them, and that's okay. If while we're working through them, if you see another one that you want to go through, that's fine. So we'll start with 2, and then we'll work our way on. Right. Some of these I'm going to give you multiple ways to solve them because there's always multiple ways to do things. So if you prefer one method over the other, go for it. For this first one, you can do this a couple different ways. One is to deal with this being a fraction, and one is to get rid of the fraction. So I'm going to show you how you would deal with the fraction first, and then we'll get rid of the fraction in the second time. So if we're trying to get m by itself, we need to get rid of this 4, we need to get rid of the 2. But anything connected directly to your variable, you don't want to start with that. Anything else is what we want to start with. So we're going to get rid of this 2, but by doing what? You can say it out loud. So in this case, we're doing the opposite. So subtracting 2 on both sides, because what we do to one side, we have to do to the other. So this would give us 8 equals m over 4. And then if 4, we are dividing by 4, we need to undo that. So how would we get rid of 4? Multiply both sides by 4. So this would give us 32. If I put 32 back in here, 32 divided by 4 is 8. 8 plus 2 is 10. We have a true statement. This is our solution. Questions on that one? Okay. This second method, you can write down if you want. If you want to just watch, that's fine. I'm going to rewrite it right next to it. If I wanted to get rid of the fraction, I would need to multiply the entire equation by a multiple of 4, usually 4 with 4. So if I take this entire thing and I multiply it by 4, I also have to multiply the other side by 4, because what we do to one side, we have to do to the other. The multiplication property of equality says that. So if I do that, I have 4 times 10 is 40. Here we're gonna end up having a fraction for a second and then not. So I'm gonna just kind of distribute this to the top. This would be 4m over 4 plus 8. The 4m over 4 would simplify. We could divide just the 4s. Now we no longer have a fraction. We did have an extra step, but that's okay. And then we would subtract 8 on both sides. So we would still end up with the same thing. We just did it a different way. Anyone have questions about that second method? Three is going to be similar in that aspect, where we have those two separate ways. One where we deal with the fraction, another where we get rid of it. So if we were dealing with the fraction, we'd have to get rid of 25. How would we do that? Plus 25, yep, to both sides. Right. Before I show you how to do this part algebraically, how do you think we would solve this next part? And then for this hand. Multiply what? We could, there is a way to multiply it, but we wouldn't do by 2/3. I'm going to go Franco and Precious.
The, what's it called? 3 over 2 numbers.
So if we multiply by 3 over 2, we can do it that way. Precious, what was your way? The same thing, okay. So I'm not going to do this method since you didn't say this. I don't want to confuse you. If you were thinking that here, these two things are multiplying to each other, and to undo multiplication, we divide, but we're already dividing with this fraction, and it gets messy like that. When you divide by fractions in a calculator, you end up with bigger numbers than what you started with, and what really happens is you're multiplying by the reciprocal, what you all sent. So what we would do here is take this fraction and flip it and multiply that to both sides. So on this side, when you're doing that, these are going to cancel, but the reason that is because you're multiplying across. So this would be 6 and 6, which 6 over 6 becomes 1. And we don't need 1p, we can just write p. But then same thing over here. All whole numbers are really written over 1. You don't see them. They're like imaginary kind of. All of the numbers you know really have an imaginary 1 underneath it. So we can make this into a fraction. That way we can multiply across and then simplify. Do that and tell me what you get for p. From 210. If we were to put 210 back in for p, we should get 115 after we simplified all that. I'm not going to do that. I know the answer is 210, but we should be practicing putting our answer back in and simplifying. Do you have any questions on that before I show you the second method? Everyone has space when you write this on on another page. So again, you do not need to write this second method down, but if you want it for reference, you're welcome to do that. So just like that other problem we did where we had to multiply the entire thing by something, we'd have to do that here as well. So to get rid of this 3 in the denominator, I'm going to multiply everything here by 3. But what I do to one side, I have to do to the other. This does say times 3, it's just really small. And I would kind of do the same thing I did before, use that like distributing method. So I'm multiplying 3 and 2/3 and 3 and negative 25. This would become 6 over 3, which we know is 2. So this would be 2p. 3 times negative 25 is negative 75. And 3 times 115 is 345. I think that's right. So now we no longer have a fraction. It looks nicer to solve. You just end up with bigger numbers. So if that is an issue for you, you'd rather not have big numbers, then just deal with the fraction. But if you don't mind the bigger numbers, then you can get rid of the fraction. So here, if I continue to solve this, and I added 75 to both sides, we have 420. And I could divide those equations. We would end up with that same answer, even though we solved it a completely different way. Do we have questions on that method? Number 6 I'm going to save for next class because that one also has 2 methods, but both methods are a little lengthy and I don't want us to run out of time. So we will move on to 8 and 10. We'll knock those out and then we'll save 6 for next class. Number 8. What do you think we're going to do first?
Y times 2y, negative 3 times negative 7.
So not the y times the 2y, but the negative 3 times the negative 7. We are doing that part. And Josie, what were you going to say? We're doing 8. I'm doing 8. Say that again. Okay, so order of operations usually we do was inside the parentheses, but can we do anything with those? No, they're not like terms, we can't combine them. So in a normal sense, if they were like terms and we could do something with them, yes, but in this case, no. We do have parentheses and something outside, so we're going to distribute. When you distribute, remember to take whatever the sign outside of it is. So whether it's positive, negative, make sure you take that or include that too. Everything else, bring down. So we're going to bring down the y. Negative 3 times positive 2y will give us negative 6y. A negative times a negative becomes a positive. So this would be positive 21 equals 76. What could we do next? Brian?
Could subtract 21 from both sides.
Okay, so if we're not following the order from before, subtracting 21 would not break any math rules. We could do that. Sometimes that's not the order in which you go in, and that's okay. You could definitely subtract that, and that'd be okay. But I saw other hands too. Casper, go ahead. Combine like terms. What are your like terms?
Y and
Correct. When you combine your like terms, you need to do whatever it says. So we're not doing inverse operations. whatever this says we're doing. So y minus 6y or 1y minus 6y is what we're doing. We end up with negative 5y equals 55. And then divide. Make sure you bring your negative when you're dividing. If you don't, you change the whole answer. So our final answer would be negative 11. Really quickly, if I put this back in, we have negative 22 minus 7, so negative 29, times negative 3, 50 something, it's really close. And then negative 11 minus that number would give us, the negative and the minus would cancel, become a plus, and we'd end up with 76. So that is the correct answer. I plugged it in for you. Do we have any questions on 8 before we do 10? This is very similar to the one on the last page where we were trying to figure out the property. Except this entire thing is being divided. We can't do anything with the 12 until we get rid of the 9. So if it's being divided by 9, we would do what to get rid of that 9? Multiply. I'm going to put parentheses around it just so I know I'm multiplying the entire thing. And then also multiplying the other side by 9. Instead of like distributing the 9 to everything as we did before, I'm just going to say this 9 and this 9 cancel. So we have our k minus 12 equals negative 18. And then it becomes a lot simpler. So now we can just move 12 to the other side. Yeah. So if you move the 18, I'm just going to rewrite this. You could, to answer your question, no, it does not matter. But if you move 18 over here, you end up with something on this side, 0 on this side, and you still have to solve for k. You haven't gotten k by itself in this instance. So you created an extra step for yourself, which is fine. You would just have to keep that in mind. Questions on that one? Okay. So we're going to save 6 for next class. You have other practice problems on there. This is not a homework thing, but if you want to work through other practice on there, you are more than welcome to try that. The answer key is on Canvas if you would like to check yourself. We will start with that problem and then continue with others. Make sure you put your calculators back